This lesson is graphing quadratic functions in standard form. Standard form is y equals ax squared plus bx plus c. Where this a is, where this b is, and where this c is will be numbers. And we'll use those numbers to find the vertex and the axis of symmetry, which we're going to graph on our page. So here's some important vocabulary and some formulas. The vertex is the lowest or highest point. It's either the minimum or the maximum of your graph, and it's always in a coordinate point. So you're going to have an x value and a y value. To find the vertex, we're going to use this formula, x equals negative b divided by 2a. And to find the y value that goes with it, you're going to plug that x value back into the original equation. The axis of symmetry goes through the vertex, so its formula is still x equals negative b divided by 2a. But this time we don't have to find out what the y is because the axis of symmetry is actually a line, whereas the vertex is a point. Okay, so let's try this and see what we've got. So for the first problem, y equals 2x squared minus 8x plus 6. 2 is my a, 8, or I should say negative 8 is my b, and 6 is my c. So the formula for the vertex is negative b divided by 2a. So for our equation, x equals negative b, which is negative 8, divided by 2 times a, and a is 2. So 2 negatives makes a positive. This is 8 divided by 4, which is 2. That's the x value of our vertex. To find the y value, we're going to take this x value and plug it back into the original equation. It looks like I may be out of space, so I'm going to erase this right here. Okay, so y equals 2 times 2 squared minus 8 times 2 plus 6. That's this equation up at the top, except for where the x's were, I replaced those x's with 2's. Y equals 2 times 4 minus 16 plus 6, which is 8 minus 16 plus 6. 8 minus 16 plus 6 is negative 2. So the vertex is at 2, negative 2. So the vertex of this problem is at 2, negative 2. That's going to be the vertex when I go to graph it. The axis of symmetry is the same exact formula, negative b over 2a. Well, we just did that. We already know what that is. That's 2. So x equals 2 is my axis of symmetry. It's called the axis of symmetry because the line goes straight down the middle of the parabola. And then the next thing I want to find is the y-intercept. So let's rewrite this equation. 2x squared minus 8x plus 6, and it was equal to y. Remember that this is a, this is b, and this is c. Alright, to find the y-intercept, you plug in 0 for x. Okay, so in my equation, y is going to equal 2 times 0 squared minus 8 times 0 plus 6. That 0 doesn't look very good. Let's try that again. 0. So 2 times 0 squared is 0, minus 8 times 0 is 0, plus 6. So my y-intercept is 6, which also happens to be c. Okay, that's actually not a coincidence. That's how it's going to work. So if I want to graph this equation, make myself a little grid. Now I need to go at least to 6. I'm going to go back and look. What was my vertex? My vertex was at 2, negative 2. So 2, negative 2 is going to be right over here. And it's also where the axis of symmetry is, so I'm going to do a vertical dotted line so you can remember that there's symmetry there. So I also know that my y-intercept is 6, so on my y-axis I go 1, 2, 3, 4, 5, 6. Remember that because there's symmetry, if I go across over here and mirror that point, then that is where my u is going to be. That's how you graph it. So we found the vertex, the axis of symmetry, and the y-intercept, and using those things we were able to graph this equation. This problem has a minimum because it has a low point. The lowest point is called the minimum. So this vertex is a min. Okay, let's try another one. I learned from my experience last time, so we'll erase this. The vertex x equals negative b divided by 2a. B is right here. A is right here. C is not being used at the moment, but we know that in a little bit it is going to be our y-intercept. That's useful, except for I went off the page. Okay, so for the vertex, x is negative b divided by 2a, so it's negative 6. Divided by 2 times 3, which is 6 divided by 6, which is 1. So the x component of my vertex is 1, and if you recall, the axis of symmetry uses the same formula. So the axis of symmetry is x equals 1. Alright, so now I just need to find the y value that goes with my vertex. So y equals 3 times 1 squared minus 6 times 1 plus 4. That's taking this equation up here at the top and plugging in 1 for my x values. So 3 times 1 squared is 1, minus 6 times 1 is 6, plus 4. So 3 minus 6 plus 4. Remember your order of operations when you're doing this. So 3 minus 6 plus 4 actually equals 1. So my vertex is at 1, 1. My axis of symmetry is at 1, and my y-intercept up here is going to be 4. So 1, 1, 1, and 4. Let's graph this. The vertex was at 1, 1, which is right here. The axis of symmetry goes through the vertex point as straight as I can, not a very straight line drawer. So the vertex is on the axis of symmetry. I found my y-intercept to be 4, which is right here. If I go and make a mirror point right here, which happens to be at 2, 4. So this point and this point, so these 3 points together, when I connect them and make a U, I have my parabola. This is a very yucky drawing. I did not do a great job, but hopefully you can see that goes through 0, 4, and that's my parabola. This time we have a min because we have a low spot. Okay? Remember that we know that it's going to be a u because of the x squared. X squared makes the u. This is your problem to do on your own. Y equals negative 2x squared minus 6x plus 3. You need to go ahead and find the vertex. You need to go ahead and find the axis of symmetry. And you need to go ahead and find the y-intercept. And then graph it.